So for the ith candidate to win, the votes that the ith candidate received should be maximum. But if it is not the case, okay, there will be two conditions. So suppose there are two people. We are considering the ith candidate, and there are two other people. So there are two cases. In the first case, there is some candidate J such that J is less than I. The number of the candidate J is less than the number I, and f of J greater than or equal to f of I. So in this case, there is a candidate J less than candidate I such that f of J greater than or equal to f of I. In this case, we need to exclude this particular candidate, since here the number of votes for this particular candidate is clearly larger, right? Now if this case occurs, if a case like this occurs, we need to exclude all the candidates lesser than I. So why is that? So when we exclude the candidate J, the number of fans of J will get added to C, right? So C initially had some value, and now C is the number of people who doesn't have a favorite candidate. So the fans of J will get added to C. Now C will vote for the candidate with the lowest number, right? Suppose K is the candidate with the lowest number. These C people will vote for K. Suppose initially K didn't have any fans. So in the worst case, K didn't have any fans, and C was also equal to 0 before this. Now C became equal. C was equal to 0 before this, and now C become equal to f of J, and K didn't have any fans. So since K is the candidate with the lowest number, all these people will vote for K now. So this 0 will get transferred to f of J. So now f of J people will vote for K, and we already know that f of J greater than or equal to f of I. So now there became another person K such that f of K greater than or equal to f of I. Even in the worst case, even if K doesn't initially have any fans, this will occur. That's why I took K as the number of fans for K as 0 initially. Even in the worst case, this will occur. Even in the best case and the worst case, this will occur. So this is bound to happen. So till there are some candidates lesser than I, this process will keep on repeating. So until we exclude all the candidates lesser than I, this process will keep on repeating. So we have to exclude all the candidates lesser than I. Okay, now this is for the case where for this condition. Now we will examine for the second condition. Second condition is where J greater than I and f of J greater than or equal greater than f of I. So there is a candidate J greater than I, and the value for the candidate J is greater than the value for the candidate I. So in this case, it's obvious that we need to exclude this candidate J. But the thing is that if we exclude this particular candidate J, this f of J will get added to C, right? The f of J will get added to C. So C will be equal to C plus equal to f of J. So f of J will get added to C, and this C number of people will vote for K. k, where k is the lowest number or the minimum number, the lowest number. So in the best case that we talked about earlier, the minimum number of fans will for k will at least will be equal to f of j, and since we already know that f of j greater than f of I, it will f of k will also be greater than f of I, and this is a value lower than, so, and since this is the lowest number, this will be a value lesser than I. So suppose there are some candidates lesser than I. So since this is the lowest number, since there are candidates lesser than I, this will be candidate lesser than I. So the same process above same process will happen again. The same process will happen again. So we have to exclude all the candidates lesser than I, even in this case as well. So we have to exclude all the candidates lesser than I, even in this case as well. So yeah, so it's bound to happen. So if we if the j greater than I, and if f of j greater than f of I, we need to exclude all the candidates lesser than I, and after we exclude all the candidates lesser than I will become the lowest number, right? I will become the lowest number. Since there are no candidates lesser than I will become the lowest number, and all the fans of the people that we excluded will get added to I. So suppose the sum of all the fans that we excluded, okay, actually it is equal to C, right? The sum of all the fans that we excluded will be equal to C plus C had some initial value, so C will be equal to C plus equal to the sum of all the fans that we excluded. Now we will check whether f of I plus C is greater than f of j. So the excluding all the candidates below I happened because of this condition, right? Because there was some j such that f of j was greater than f of I, so we had to exclude all the candidates below I. Now all the fans of the candidates that we excluded below I got added to f of I. So all the fans of the candidates that we excluded below I got added to f of I right now. Now after it got added to f of I, now we will check whether f of j became lesser than or equal. If it became lesser than or equal, there will be no need to exclude f of the jth candidate. But if it's still adamant, and if it's still greater than f of I plus C, if f of j is still greater than f of I plus C, then we have to remove the jth candidate as well. So there was some writing over here already. We have to remove the jth candidate as well, and we have to add so the number of candidates, the total number of candidates that we removed for the ith candidate to win is I plus 1. So we removed all the candidates below I. So there are I candidates below I, since it's a zero based indexing, and after we remove all the candidates below I, we will check whether whether this condition satisfies, whether f of I plus E became greater than or equal to f of j. If it became greater than or equal to f of j, we don't need to add this extra 1 because we are not going to remove this jth candidate. But still, if f of j is greater we will remove this jth candidate and we will add 1 to this sum. After we remove f of j, we are 100% sure that ith candidate will have the highest number of votes, because like since now the ith candidate is the candidate with the lowest number, right? Because we excluded all the candidates below I. Ith candidate is the candidate with the lowest number. So when we remove the exclude the candidate j, the fans of this j will get added to I. So now I will surely have the highest value, the highest number of votes. So this is the explanation for the problem. Now I will explain the code for the particular problem. Hello guys, so this is the code. So I am inputting the array over here, and inside this variable I am storing the sum till the ith index, the sum of all the sum of all the values till the ith index, and the maximum value till the, and inside this variable I am storing the maximum value till the ith index. And inside this vector, okay, so initially we had some c, right? We got some c. So this c initially will get added to the guy with the candidate with the index 0, because he has the lowest number right now, and c will get added to him. And inside this array max from I, what I'm going to store is the value which is maximum after this particular index I. So I am basically using a priority queue for that. I am iterating from the back and I am pushing into the priority queue, and the element at the top will be the maximum element. So I am storing it for the ith index. I am storing it. So max from I of I is the maximum value after I. Yeah, maximum value after I. This variable will store the maximum value till the ith index. So since we are iterating from say, the 0 to n, a variable is enough. But we have to use an array over here. I will show you. So this is the main function loop. I'm iterating from 0 to nth index. So the count will store the so the count will store the number of candidates that we need to exclude for the ith candidate to win. So the value for the ith candidate, the number of fans for the ith candidate, or the number of votes for the ith candidate is equal to vec of I initially, and I will check whether this value. So if a can if some candidate after I has value greater than the value vec of I, or if some candidate uh, till I have value greater than or equal to vec of I, what I'm going to do is that I'm going to eliminate all the candidates below I. So I'm going to eliminate all the candidates below I. So the number of candidates that we eliminated will be equal to I, and I'm going to add the sum till I. Sum till I is the sum of all the uh, fans for all the candidates below I. I'll add that to the value. The value initially is equal to vec of I. I will add this sum till I to value. And why are we checking max from I greater than value and max till I greater than or equal to value? So why are we not using a greater than or equal symbol over here? Because it is mentioned that so if we are on the ith index, and if we are checking for indexes after the ith index will be the lowest index, right? So since it is the lowest index, even if there is a value equal to even if there is a value equal to a value even if there is a value equal to vec of I after I, we will choose the ith candidate because it's mentioned in the problem statement, right? So if there are two candidates with the equal maximum number of votes, we will choose the candidate with the lowest number. So since I will be lower than I will be a lower number than all the candidates after I, we don't need to check for the equal condition. But when we are checking till I, so till I, so the candidates that we are checking inside this till I will be, so the candidates that we are checking inside this variable will be lesser than I. So here I will be greater than the candidates that we are considering. So we have to check for the equal condition as well because I is greater over here than the candidates that we are considering. So we have to check for the equal condition as well. So it's mentioned in the problem statement. Now after we have eliminated all the values below I, all the candidates below I and added it to the sum. Now we will check whether still max from the value after I is greater than value. If it's still greater than value, we will exclude this value as well, and I will add it to the count, and I will push it to the answer vector. I will print the answer vector at the end. I will update the max till I, and I will update the sum till I as well. This is the solution to the problem. Can you comment down below whether you have understood the solution and or how can I improve my explanation skills in the future? Thank you.